Hi, this is Prasanna from Wave Academy. In this video, we are going to discuss about how to develop non-inverting buck-boost converter with the help of Matlab. Before we moving on to this topic, first we'll discuss a conventional buck-boost converter. So if you take a conventional buck-boost converter, it will always produce an inverting output because of the negative term in numerator. So this will create a inverse output that should not be applied in most of the applications. So we are going for non-inverting buck-boost converter. First we'll discuss how a conventional buck-boost converter is working with the help of Matlab, and then we'll move on to this topic. Now I'm sharing the screen. This is a buck-boost converter. I'm sharing the video link for buck-boost converter also. So if you take this is the input DC voltage source, and this buck-boost converter consists of a diode and a switch. On input side you will be having a switch, and output side you will be having a diode. Notice that the diode is connected in reverse mode. So if you measure the voltage across this resistor, you will get output voltage in the inverting manner. For an example, if you take the pulse, if I am using the pulse width of greater than 50%, it will act in boost mode. If my pulse width is less than, that is a duty cycle is less than 50%, it will act in boost mode. In this case, for an example, I am taking my pulse width is 35%. Okay, so if you run the system, look at this. It's working in buck mode, but I'm getting a negative output voltage minus 10 volts because of inverting output. At the same time, if my pulse width is, that is duty cycle is more than 50%, let me take 78%. At the time also you'll get the same kind of output. It's an inverting output, but it will be in the boost mode. So whatever the input voltage I'm using, it's 20 volts. Okay, this is enough for me. See, my input voltage is 20 volts. If you look at the case, the output is almost getting minus 59 volts. It is working in boost mode, but it gives you only inverting output. Suppose if you want here itself, if you want a non-inverting output, you have to add a component called abs. That is nothing but it is absolute. So what is the function of absolute? If you give minus 5 as an input, it will give you plus 5 as output. If your input is plus 5, it will give you positive 5. Okay, whatever the case, irrespective of change in sign, this absolute terminal, this absolute block will give you only positive output. So if you place this absolute here, you will get positive output, that is inverting output. No, sorry, you will get non-inverting output. So whatever the pulse, whatever the duty cycle I'm using, it's only more than 50% as of now. Okay, let me stop it here. So my pulse width is 75%, and the output is almost, it is coming around 59% in a non-inverting mode. So it is working in boost mode. If my input is, let it be, it's 25%. So here you'll be getting the output voltage in buck mode, but it is in non-inverting mode. So this is the way you'll use the buck-boost converter in a non-inverting mode if you use absolute. But it's practically not possible to implement this kind of absolutes. Instead, there is a technique called non-inverting buck-boost converter. Okay, so that non-inverting buck-boost converter consists of two switches and two diodes. Okay, so a pair of one switch and one diode for boost mode and one switch and one diode for buck mode. Now we are going to discuss now. Let me open a blank model for my non-inverting buck-boost converter, and these are the operating modes of non-inverting buck-boost converter. I already mentioned this circuit consists of two switches, buck switch and boost switch. So, okay, we have to follow this combination of operations that will operate the circuit in buck mode, boost mode as well as buck boost mode. Depends on the controls. First we'll discuss one by one. Let me take a DC voltage source. So whatever the DC voltage source I want is I'm going to use, let it be 20 volts. Anyway, I will let you know the values later. I need two switches. Take IGBT. I don't want this M port. Okay, it's a measurement port. So I'm disabling that port. Similarly, I want two switches. And I need a diode. Here also I don't want the M port, so I'm disabling the M port. It's nothing but it's a measurement port. So let me rename this switch and diode. This is boost switch. This one is buck switch. Similarly, I'll replace this name, rename it boost diode, and this one is buck diode. This is for our easy understanding. And I need an inductor, capacitor as well as a resistor. Series RLC branch. So this will act as an inductor. This one is capacitor. And this one is load resistor. So this is actually the resistor, inductor and capacitor all are connected in series. I want only the inductor or capacitor or resistor, depends upon your application, you can choose it. So now I'm going to select only inductor here. In this case capacitor alone, and this one is resistor. So values and all I will apply later. First we'll finish the circuit. So you'll be having a buck switch in the input side, and buck diode in the input side. Connect like this. And there is an inductor. Similarly, you will be having a boost switch as well as boost diode on the output side. If you want to rotate, you can use Ctrl plus R. And if you want to measure the output voltage, you can use a voltage measurement. I want two voltage measurement because I want to compare both input voltage as well as output voltage. So voltage measurement should be connected in parallel with the input voltage and output voltage. That is the basics of any electrical systems. I'll change the background of scope for better visibility. Go to view style. So it depends upon your requirement, you can choose the background. Figure color as white, axis color as white, pen as black. Take channel 1, let it be, this is 3. So channel 1 is input voltage. I want the input voltage should be in black color. Accordingly, you can add legend. Channel 2 is output voltage. I want that output voltage in, let it be red color. So this is the typical non-inverting buck-boost converter, which consists of two switches. Input side will be having a buck switch and buck diode. In output side will be having a boost switch and boost diode. But here the very important part is operating these switches. So operating these switches is purely based on this table column. Okay. So at any one time, at any one case, you can control the switches in at the same time. The other switch will be either it will be off state or on state. Suppose if you are controlling both switches at the same time, then that circuit will work in both buck-boost mode, depends on the duty cycle. So that we'll discuss in detail now. So if we want to switch, if I want to activate the switch, I need a PWM or pulse generator, let it be. So this is a pulse generator. Okay. So let me fix the values. So let it be, it's a pulse type is time based, amplitude is 1, and whatever the period I'm going to use is 2 e power minus 5. 2 e power minus 5. So everyone know that this formula F is equal to 1 by T. That is, frequency is inversely proportional to time. This time is nothing but 2 e power minus 3. So what will be the frequency? So 1 divided by 2 e power minus 5, that is equal to coming around 50,000 Hz, 5 kilohertz, sorry 50 kilohertz. 50 kilohertz is the switching frequency of this non-inverting buck-boost converter. Okay. So I'm wrongly entering this one. This is period 2 e power minus 5 here. So 2 e power minus 5 is here. Okay. So pulse width I will do it later. Apply. Okay. So whatever the input voltage I am using, it's 20 volts, and inductor value let it be, it's 47 millihenry. 47 e power minus 3, that is 47 millihenry is the inductor value I am using. And capacitor, let it be, it's 100 microfarad. And whatever the resistor you are using, let it be, it's 100 ohms. Let it be, this one is 100 ohms. Now, what is the first condition if the circuit wants to work in buck mode? So yes buck, that is buck switch should be controlled by PWM and boost switch should be in off state. So let me first select this portion, this one, operation 1, buck operation. Okay, so let me take this case. So now according to this table column, buck switch is this one. Let me close this because I don't want to confuse. Yeah. First option, buck switch will be controlled by PWM, boost switch will be in off state. Okay, so buck switch control will be controlled by pulse generator. What about this boost switch? This should be in off state. How to make the switch off? Either you can on the switch or off the switch. Okay, so let me take a constant block. So make sure that the constant value is 0, which means that the switch is off state. Okay, so now the condition 1, buck switch is controlled by the pulse generator, whereas boost switch is in off state. 3 seconds is more enough for us. Save the system. Don't bother about this pulse width. Okay, either it will be 25%, 30%, or if it is greater than 50%, let it be, it's 75, 80. All the cases, this circuit will work in boost mode alone according to this table column. Okay, so as of now, you need not to bother about what is the pulse width. For an example, even if you are selecting, let it be, it's 70%, it will work only in boost buck mode. Apply. Okay, run it. I forgot to add a power guide. Power guide is mandatory. Let it be continuous, nothing. And it. You can stop it by 25% itself because we want to check whether output is coming or not. See, the input voltage is 20 volts and output voltage is coming around 13 volts. So now it is working in buck mode. It's clear now. What is the second operation? Yes, buck must be on state. You should not off it, because if you off this switch, buck switch, the entire circuit will be disconnected from the power supply. Okay, that is very important. So buck switch must be in on state. The boost switch will be controlled by PWM. This is the second operation. What I am doing is, I am disconnecting this one. Now the boost switch will be controlled by PWM, whereas buck switch is always in on state. Make sure that this constant is 1. Don't go with 0. It won't work. Circuit won't work. You can check it out. Save it. Let it be. The pulse width is same 70%. It will work in boost mode. I'm stopping here. See the output. The input voltage is 20 volts and the output voltage is coming around 66 volts. Now it is working in boost mode. Okay. What about the third condition? You can control both switches with the help of PWM. So now what you can do is remove this constant block. Now connect both switches with pulse generator. So now pulse width plays a major role. If your pulse width is, that is duty cycle is less than 50%, it will work in buck mode. If your duty cycle is more than 50%, the same circuit will work in boost mode. This is now important. For an example, if I am choosing my pulse width is 35%, which is less than 50. If your pulse width is 35%, at that time this circuit will work in buck mode. Look at here. This is your input voltage, it's 20 volts and output voltage is coming around somewhere approximately 8 volts. It's working in buck mode. I'm stopping the simulation. Just go to pulse generator, change the pulse width, which is choose any values higher than 50%. Let me take 80. Apply. Okay. Run it. See the output. Input is 20 volts and output is coming around somewhere 78 volts. It's working in boost mode. Okay. This is the way you can develop non-inverting buck-boost converter with the help of Matlab. And while executing the non-inverting buck-boost converter, these operating conditions are very important. Okay. So if you want to work the circuit in buck mode, yes, buck, that is a buck switch will be controlled by PWM, whereas boost switch will be in off state. If you want to work in the same circuit in boost mode, yes, buck, that is switch buck should be in on state, whereas boost switch can be controlled by PWM control. If you want to operate in both modes at the same time, buck boost mode, you have to connect both the switches with the help of PWM control. I hope this video will greatly help you to develop non-inverting buck-boost converter. Thank you. Kindly subscribe to the channel. If you have any queries, kindly drop a mail to this mail ID. Thank you.